Hi guys, I am Krishnakant Goyal and I'll be teaching you how to solve flare furniture problem using solver. So let us focus on the screen now. As you guys must refer to page number 253 of our QTM textbook. वहाँ पे आपको सारी इक्वेशंस और ऑब्जेक्टिव फंक्शन मिल जाएगा. ऑब्जेक्टिव फंक्शन आप दे सकते हैं इज टू मैक्सिमाइज द प्रॉफिट 70t plus 50c, where t represents the number of tables and c represents the number of chairs to be produced. Now the constraints which are given are the carpentry constraint and painting and varnishing constraint. These two equations, and there are two non-negativity constraint as well. First is t should be greater than equal to 0. The other one is c should be greater than or equal to 100. Now let us go to the screen. First, variables. Our variables are table and chair. Say suppose if initially we are producing number of units as 1 and 1 and our objective function is 70t, then we'll write the coefficients of these 70 and 50. Now how to represent this equation of maximizing profit is 70t, then that would be formula would be 70 into t. Now initially we have taken the solution as 1, so it would be 70 into this plus 50 into this. Now next are the constraints. C1.
Could you please explain how did you get the formula again? उसको मतलब कैसे exactly लिखा तूने, एक बार बता दे. वो 120 को वापस ले आओ, 120 वाले पार्ट को.
As you can see in the objective function, our objective function is to maximize the profit and the equation that is given is 70t plus 50c. Initially we are supposing that our solution, initially we are supposing that we are producing one table and one chair. This is just an assumption. The solver will give the final solution. So suppose if we are producing one table and one chair, how will you write it in the equation form? It is 70t plus 50c. Now if we'll focus on the screen, 70t plus 50c. If we have to write this one in formula, how we will write? We'll first use equal to mark, then 70 into t. Now t here is 1, so it would be like this, plus 50 into c. C here is 1. We forgot to write into just a second. This into this. Then we'll press enter and we'll get 120. Okay. Now our constraint 1 is the painting. Oh sorry, carpentry constraint. So similarly, as we have written the maximizing profit equation, we'll write the constraint equation as well. So the coefficient for table in first constraint is 4, and for carpentry it is 3. Similarly, for constraint 2, the coefficient of table is 2 and for the coefficient of table chair is 1. This part is clear? Okay. Now similarly, as we have done for the objective function, we will do for the constraint as well. So how to write the equation for constraint? Same, equal to 4 into number of tables. The number of table again is 1. So just a second. 4 into number of tables plus 3 into number of chairs, and then enter again. Similarly for constraint 2, first we'll put the equal to, then coefficient into number of tables plus coefficient into number of chairs, then again enter. Now if we'll focus on our textbook, it is given that 4t plus 3c should be less than equal to 240 and 2t plus 1c should be less than equals to 100. So we'll write the same equation here as well, that this should be less than or equal to 240 and this should be less than or equals to 100. So here we have formulated our linear programming. Now comes the solver part. Or if you want to format it like doing this, put it into Times New Roman into 12 font and central line, giving them some colors just to give it a better format. Put it in a table. You can do all these, but our main aim is to get the optimal solution. So now go to the data. Now on the right hand side you'll get the solver. Now our target cell is this cell, because this represents the objective function. So once you go into this dialog box, select this, delete this one and select this, then click here. Now our objective function is to maximize. If it would have
क्या select किया वापस बता दो, वो आया नहीं.
टारगेट सेल, अपने को क्या प्रॉफिट, अपने को क्या करना है, अपना मेन एम क्या है, अपने को जो अपना प्रॉफिट है वो मैक्सिमाइज करना है. तो यहाँ पे जो टारगेट है वो मैक्सिमाइजेशन ऑफ प्रॉफिट है. तो जो आपका सेल मैक्सिमाइजेशन प्रॉफिट का वो दिखा रहा है सॉल्यूशन, उसको अपन सेलेक्ट कर लेंगे. यहाँ पे गए अपन और अपना कौन सा वाला सेल है, वो यही तो सेल है जो अपन ने इक्वेशन में निकाला था. इसको सेलेक्ट करा और यहाँ पे क्लिक कर दिया. ठीक है. अब अपने को क्या करना है, इक्वल टू मैक्सिमम मिनिमम और वैल्यू ऑफ, मतलब अपने को बेसिकली सेल को क्या करना है, मैक्सिमाइज. ये तो था अपना फंक्शन, तो मैक्सिमाइज कर दिया. अब चेंजिंग सेल कौन से है, अब अपन क्या चीज चेंज कर सकते हैं, या तो नंबर ऑफ टेबल प्रोड्यूस या नंबर ऑफ चेयर प्रोड्यूस, या नंबर ऑफ टेबल प्रोड्यूस और नंबर ऑफ chair produce. Now number of table and chair are represented in these two cells. So here by changing cells we'll click here and then go to that side. We'll select these two. After selecting these two we will click here. Okay, now as you can see what is subjected to constraint. Here we have to select our constraint. So go to the table again. Here when just one more second onto that side, click on, sorry, वापस हो गए. First our constraint is this constraint. Add. Selecting this should be less than and equal to, what is our constraint, 240. Okay, add this one. Now next is this should be less than equals to this, again add. Then we have done for both the constraints. Put and okay, we can put. Now here you can see the two constraints are here. Okay, now go to options and assume it is a linear model and non-negative. Linear, as you are doing for linear programming, and non-negative are the last two constraints for table and chair. Remember we have taken the number of table and chair should be produced, then should not be negative. Put an okay and then get solve. Now if what all reports do you need, the answer, sensitivity and limits are the options. So we need all the three reports, so click on all the three and press okay. So now here you can see our solution has changed from 1 and 1 to 30 and 40, which is the correct solution.
Optimal solution.
Correct solution as per group, and it is known as the optimal solution. But our question does not end here. Does not end here. अपने को profit भी बताना है. So our profit is, as you can see, is 4100, which is also correct. So the number of tables which would be produced is 30, and the number of chairs which would be produced is 40. This represents our optimal solution, and profit is 4100. Now if you go at the bottom of your screen, you will find some answer report, sensitivity report and limit report. First one is the answer report. The answer, as you can see, original value अपन ने 1 और 1 ली थी, नंबर ऑफ टेबल एंड चेयर प्रोड्यूस, उस हिसाब से अपना प्रॉफिट आ रहा था 120. बट जब अपने सारे कंस्ट्रेंट्स डाल दिए और उसके बाद अपन ने सॉल्वर को यूज करा तो अपनी जो फाइनल वैल्यू आई 30 और वो 40 आ गई. तो 30 would be the number of optimal tables that you would produce and 40 would be the number of chairs for the optimal solution, and the the final value of profit would be 4100. Now if you come at the bottom, you can see these two are binding constraint. As by theory we know the binding constraints are those who have slack 0, or vice versa. If any constraint has a slack 0, they are known as binding constraint. Okay, so all this would you would find in the answer report. Now when you will go to the sensitivity report, so here you will found these two tables. One would be for, see, the final value of table that we have produced is 30, and the final value of chairs that we will produce is 40. Now as you can see, the objective function 1750, these are the coefficients in the objective function. Now here you can see two columns, allowable increase and allowable decrease. These are for the insensitive range. What is an insensitive range? It is that range within which if we will change the coefficient in the objective function of our variables, then the optimal solution will not change, only the profit will change. So 70 and 50 represents, 70 represents P1, 50 represents P2. So the range of P1 would be 70 minus 30 and 70 plus 3.33. So if we will do 70 minus 30, that would give us 40, and if we will do 70 plus 3.33, that will give us 73.33. So our range for P1 would be 40 to 73.33. Similarly for P2, our range would be 47.5 to 65. So these two range, P1 and P2, will represent the insensitive range within which the optimal solution will not change, only the profit will change. Now if you see the other table, these are for the constraints. This represents the sensitive range. That means you can change the value within this range. For example, the right hand side of the constraints were 200 and 240 and 100. Now there are two things. First is the shadow price. The shadow price for the first constraint is 15 and the second constraint is 5. Whereas the sensitive range for the first constraint would be 240 minus 60, that is 180, and 240 plus 40 is 280, that is 180 to 280. That would be B1, and B2 would be 100 minus 20, that is 80, and 100 plus 20 is 120. That yani B2 would be 80 to 120. So in this way we can get the sensitive range of the constraint as well. That's all for now. Hi guys, before we proceed towards next question, let us first see how to install solver in Excel. Go to the left upper corner, click here, select Excel options, go to the left hand side of this dialog box, click on add-ins. Now as you can see this solver add-in option over here, click on this, go to drop down list, select Excel add-ins, click on go, and then OK. As and when you will click on this OK option and go to the data menu, on the right hand side you can see solver has been installed in your Excel. Now as in the previous case we had two variables. Now if there are such cases where there are more than two variables, say for example in the Mexicana wire works case we have total 4 variables. So let us see how to solve the linear programming which is having more number of variables using solver. Now variable, as we can see in this case there are 4 products, so we have taken 4 variables A, B, C and D. The number of units that would be required to produce for this will represent our optimal solution. So as we have taken in the Flair furniture case, initially the number of units that we are producing is 1 for each variable. The coefficient of objective functions are 34, 30, 60 and 25. Now how to get this 149? This 149 represents the sum product of our variable and unit produced. So one method you have seen in the Flair furniture problem. Now I want to show you the other method. Click here, equals to, then write sum you product, and you can see this formula. Double click on this. Now select the entire row of unit produced, comma, back here, and then select the entire row of objective function. Close the bracket and press enter. So this 149 would become our profit cell. Now constraints. Now there are 10 constraints, and similarly as we have done in Flair furniture problem, we can write down the equation for these constraints in this manner. Now again, the sum product of all these constraints. How to get this?
Just show one. Just show one.
Okay, just press equals to, select this entire row of unit. Oh sorry, we have forgot to write the formula. That is the sum product. Double click on this, select this entire row, comma, select the entire row for the first constraint, bracket close, and then for the other constraint as well. Now when you will do for the other constraints, the values that you will get are these 1, 4, 7 and so on. Now these are the signs that you can write from the case. After studying the case, you will be able to form this equation. This represents the available resources for each constraint. Now let us focus how to solve this linear programming using solver. Go to solver, cell target. As in the previous case, our target was to maximize. Similarly, here our target is this cell. So when you will click here, after this you will select this cell and click here. Now here we want to minimize, so we'll select the minimize option. Just a second.
Maximization ही था ना ये भी.
I think it is a minimization problem. No, sorry, it's a maximization problem. Now by changing cells here, we will select the number of units again, like this. Now subjected to constraints, here we will click and then go to add option. Our cell reference is these two. Now why I am not selecting these two or other, because here the sign is greater than or equal to, but here the sign is less than or equal to, so we have to add another constraint for these. Then it is greater than or equal to, and constraints are 150 and 600, so first const is added. Similarly for all these sign, as you can see, all these sign are similar.
तो फिर सबको एक साथ select कर सकते
We
हैं.
can select all this, then these are less than or equal to, first you can check, and then constraint are, now you can add this one as well. So we have done for all these. Now go to options, assume linear model and assume non-negative. I have explained earlier why I have done this. Okay, solve all these three answers and okay. So now as you can see, the number of unit produced are this and the optimum solution is this. Similarly, you can go to the answer report. Initially we have assumed the number of unit produced for 4 different variables are 1, 1 and 1, but in the final solution we will be producing 1100 for A, 250 for B, 0 for C and 600 for D, and the other details are given in the other tables. That's it. Thank you.
Thank you, KK. I hope this is